presentation. In this lecture, we will study three things. The first one is state table, the second one is state diagram, and the last one is state equation. I am having a sequential circuit on the left hand side of my screen, and it is actually not a complete sequential circuit because I have not shown the internal circuitry, and it is not required at this point of time because you have to learn the basic of a state diagram, and from the next presentation we can carry on with the complex circuits. In this you can see there is one input X, two flip-flops are used, both of them are JK, and one output Y is there. Now the first thing comes state table. So state table. In sequential circuit, we use state table instead of the truth tables. You remember in combinational circuits, we use the truth table to get the information about the circuit, and by knowing it, we know how the connection is there and what types of gate are involved. Similarly, by using the state table, we can know the connection of a sequential circuit, how input and outputs are connected and how flip-flops are connected also. So I can say that a state table is the table which tells us about the relation between the present state, next state, and the outputs. The present state and next state you already know. So I can make a state table in which the first column represents the present state, and present state will be determined by knowing the value of QA, QB, that are simply the output of my two flip-flops used. Then this state will be changed by the value given to this sequential circuit, and we are giving X. So X is my input, and depending upon X, the state will change. So in the next column, I'm having the next state, and the next state is QA plus QB plus, and finally my output Y. So this is a simple state table, and by using this state table I can have my state diagram, which is very important. So let's see what is a state diagram. The first step is to know how many states are there, and it can be done by looking to the number of flip-flops. There are two flip-flops and two outputs, QA and QB. Therefore I can have 2 to the power 2 equals to 4 states, and they are written as S0. S0 is my state 1, and it is 0 0. QA is 0, QB is 0. The second state is S1, 0 1, S2, 1 0, and finally S3, 1 1. Now each of these states from S0 to S3 is represented by a bubble like this. Okay, and as there are 4 states, I am having 4 bubbles. This first one represents S0, in which the value of Q and QB are 0 0. Second one is 0 1, S2 1 0, S3 1 1. If you want to write this value 0 0, it's okay, or you can just simply write S0, S1, S2, and S3. As this is the first lecture, I am writing these things down. Now let's see what is the next step of ours. You have to see the present state. Let's say the present state is 0 0, and the input when the present state is 0 0 is 1. Then the next state will become, let's say, 1 0, and the output is 1. If this is the case, we don't know the internal circuit here, but I am just assuming I'm taking a random output and random next state, and I have written it here, and I'm just using it to show you what is the state diagram. So we are at 0 0, it means we are at S0, and the input given is 1, and once I give the input as 1, our next state becomes 1 0, and 1 0 is S2. So I will go to 1 0, and an arrow will be there showing that I am shifting from S0. Now we have to also give information about the input and output, so that we may know that what input made us to move from S0 to S2. So X slash Y. X is my input, Y is my output. This is the way to show the input and output in my state diagram. So the input was 1 and output was 1 as well. Similarly, we can check for the rest of the cases, and we can make our state table. It will look something like this. It may be anything depending upon the logic given here. So this is a simple state diagram, and in this presentation I am going to make the state diagram for JK flip-flop. This is the characteristic table for JK flip-flop, and I can use this characteristic table as my state table because there is no external input like X and output like Y. We are just having a flip-flop that is JK. The inputs are J and K. This is my input, and the present state is Qn, and the next state is Qn plus 1. So I can make a state diagram easily. Two possible states are there because only a single flip-flop, therefore two possible states. S0 is 0 and S1 is 1. So I will make two states. This is S0, this is S1. Let's check for the first case, and in this you can see that the present state is 0. It means we are on S0, and when we make j equals to 0, k equals to 0, the next state will also be 0. So this thing is shown like this in state diagram, and we also have to write the input. So the input is 0 0. Okay, similarly we will check for the second case, and here the present state is 0. It means we are on S0, and when we make j equal to 0, k equal to 1, we are again going to be on 0. It means the same arrow is going to do the work, but we have to change the inputs. It is 0 1, and we can now see that j is 0 0, whereas k is don't care. So I will rub this thing, and I will write 0 don't care. Okay, similarly we will check for the third case when the present state is 0 and j is 1, k is 0, the next state will become 1. Now this time we are going from one state to other. We are on S0 and we are going on S1, and in that case j is 1, k is 0. Similarly we will see the fourth case. The present state is 0, we are on S0, j is 1, k is 1, the next state is 1. So 1 1. Again you can see that 0 1, our k is 0 1 and j is 1 1. It means k is a don't care, and I will rub this thing down and I will write 1 don't care. So this is the way to make a state diagram. I will complete for the rest 4 cases, and in the fifth case you can see that the present state is 1. So I am on S1, and when we make jk 0 I'm going to be on S1. So again I am on S1 when j is 1, k is 1. When j is 0, k is 0. For the sixth case, I am on S1 and I will be on S0 when j is 0, k is 1. So S1 to S0, j is 0, k is 1. Very simple. For the seventh case, I am on S1. You can see I am on S1 and I will be on S1 when j is 1, k is 0. It means we have to include more inputs here for the same transition, and I will rub this thing down. And before rubbing it, let me tell you that j is a don't care, k is a 0. So we can write it don't care 0. Now let's check for the last case when the present state is 1 and the next state is 0. It means I'm going from S1 to S0 when both of the j and k are 1. It means again the don't care is involved, and the don't care in this case is j. So j is a don't care and k is 1. So this is a complete state diagram for the jk flip-flop, and it's very easy to make once you know this thing, once you know the basic. From the next presentation we will go to a much complex sequential circuit, and the state diagram obtained will be very complex as compared to this one. There are different states involved because there are more than one flip-flop, and also the transition is not that simple. So for that you have to see the next presentation, and also I believe you will revise these things down. That will help you to solve the problems in the sequential circuit. Now the last part is the state equation. So state equation is nothing but a equation in which the left hand side, the LHS, is the next state, that is Qn plus 1, the next state, and RHS is the combination of the present state and the input, and this combination, the combination of present state and input, will make the next state Qn plus 1 equals to 1. So this is a simple definition of a state equation equation, and if I make a state equation for the JK flip-flop, it will look something like Qn plus 1, the next state on the LHS, equals to Qn complement J plus, that is our OR operator, Qn k complement. RHS is having the combination of the present state and the inputs, and this combination will give the next state equals to 1. So this is all for this presentation. I'm